day, Davao de Oro. Good day, TV Eskwela viewers and listeners, especially to all grade 8 students who are watching to us right now. I am your teacher, Nelmmy Pagsanghan Ferran from Andili National High School, Mawab District. I am very excited to bring you today's lesson in grade 8 science. So, what are you waiting for? Sit back, relax, and join us as we tackle earthquake waves. Now, get your pen, paper, and your self-learning module. Be sure that you have already eaten your meal as we go through our discussion. Are you now ready for today's lesson? That's great! But before I introduce to you our topic, let us have a short review of the previous lesson, which is about earthquakes, epicenter, and magnitude. As we all know, an earthquake is the shaking of the Earth's surface resulting from the sudden release of energy in the Earth's lithosphere. A fault is a weak point in the tectonic plate where the pressure inside the crust is released. The area inside the Earth where an earthquake starts is known as the focal point of the quake, or the focus. The point at the Earth's surface directly above the focus is known as the epicenter of the quake. During an earthquake, the strongest shaking occurs at the epicenter. Now, we are done with our review. And to test your prior knowledge on today's lesson, kindly open your module on What I Know, pages 2 to 4, and try to answer the following questions by choosing the letter of your preferred answer. Are you now ready? Let us start. Pretest question number 1. What is the main cause of seismic waves? Again, what is the main cause of seismic waves? A. Earthquake. B. Thunder. C. Traffic. D. Volcano. The correct answer is A. Earthquake. Question number 2. What type of wave is P wave? Again, what type of wave is P wave? A. Electromagnetic. B. Longitudinal. C. Transverse. D. Ultrasonic. The correct answer is letter B, longitudinal. Question number 3. Why is there an abrupt change in the speed of seismic waves as they travel inside the Earth? It is because seismic waves are. Again, why is there an abrupt change in the speed of the seismic waves as they travel inside the Earth? It is because seismic waves are A. Colliding. B. Overtaking the compressional waves. C. Passing through a material with the same density. D. Going into a material with different properties and densities. The correct answer is letter D. Going into a material with different properties and densities. Question number 4. Which of the following waves travel the fastest and are detected first in the seismic station? Again, which of the following waves travel the fastest and are detected first in the seismic station? Letter A, love. Letter B, primary. Letter C, secondary. Letter D, surface. The correct answer is letter B, primary. Question number 5. Which kind of waves does not travel through a liquid? Again, which kind of waves does not travel through a liquid? Letter A, love. Letter B, primary. Letter C, secondary. And letter D, surface. The correct answer is letter C, secondary. Well done, learners! I guess you are now ready for today's lesson. This time, I will discuss with you the earthquake waves. I hope that we will be able to achieve our objectives for today. At the end of the lesson, you are expected to first, identify the different types of seismic waves. Second, recognize the motions caused by the different types of seismic waves. Third, describe the different characteristics of the Earth's layer that can be traveled by seismic waves. And fourth, explain how earthquake waves provide information about the interior of the Earth. An earthquake is the shaking of the Earth's crust that occurs naturally or by human activities. This is also part of the geological processes that result to the formation of the oceans, valleys, mountains, and plains. Over the last 100 years, scientists have learned a great deal about these processes, causes, measures, and occurrences of an earthquake. By studying earthquake, scientists were able to discover more about the Earth. But what causes earthquake? An earthquake occurs because of geologic force inside the Earth. These inner forces build up slowly and eventually become so strong that may cause underground rocks to break. When this happens, tremendous energy is released, causing the ground to move and shake. These waves of energy that travel through the Earth are called seismic waves. Seismic waves are waves of energy that travels either along or near the Earth's surface. Seismic waves behave in different ways, depending on what they encounter along the way. This energy that travels through the Earth is recorded by seismographs. Seismographs are instruments used to record the motion of the ground during an earthquake. They are installed in the ground throughout the world and operated as part of the seismographic network. Let's now proceed to the two types of earthquake waves. First is the body waves. The body waves are seismic waves that travel through the interior of the Earth. These waves are of higher frequency than surface waves. The two types of body waves are the primary waves and the secondary waves. The first type of body waves are the P waves or primary waves. These are the fastest kind of seismic waves and consequently the first to arrive at the seismic station and recorded in the seismograph. P waves are also known as compressional or longitudinal waves because of the pushing and pulling they do. P waves vibrate parallel to the direction and traveling in a push and pull motion. The second type of body waves are the S waves or secondary waves. These are waves that arrive second after P waves are being detected in the seismic station and recorded in the seismograph. S waves are slower than P waves and can only move through solid rocks, not through any liquid medium. S waves are also known as transverse waves, which create the shaking of the ground back and forth perpendicular to the direction that waves are moving. Let's now proceed to the second type of earthquake waves, the surface waves. Surface waves travel only through the crust. These are of lower frequency than body waves and are easily distinguished on a seismograph. Though they arrive after the body waves, it is the surface waves that are almost entirely responsible for the destruction associated with earthquakes. There are two types of surface waves, the lobe wave and the Rayleigh wave. The first type of surface wave is called lobe wave, named after Augustus Edward Huff Loeb, a British mathematician who worked out the mathematical model for this kind of wave in 1911. This wave is the fastest surface wave and moves the ground from side to side. Lobe waves produce entirely horizontal motion. It can travel a velocity of 4 kilometers per second and create more shaking. The second type of surface wave is the Rayleigh wave. Named after John William Strutt, Lord Rayleigh, a British scientist who predicted the existence of this kind of wave in 1885. This wave rolls along the ground just like a wave rolls across a lake or an ocean. It moves the ground side to side, up and down, in the same direction that the wave is moving. Most of the trembling felt from an earthquake is due to the Rayleigh wave, which can be much larger than the other waves. Now, let us try to answer this activity. Let's read all together the direction. Identify each illustration as to what types of waves. Write your answers on a separate sheet of paper. Hint: arrows indicate its movement. I will give you 5 seconds to answer each illustration. For illustration 1. The answer is correct, P waves. For illustration 2. The answer is correct, S waves. For illustration 3. The answer is correct, surface waves, because of its movement, which is up and down. So, what can seismic waves tell us? The different types of seismic waves can tell us more about the nature of the Earth's interior. For instance, seismologists use the seismic waves such as the P waves and the S waves to determine the distance from the source of the earthquake by getting the direction and the difference in the time of arrival of the waves. This means that at depth, the rocks are denser. When it reaches the upper part of the mantle, the waves will slow down. This means that the rocks are partially molten. As the waves reach the core, one kind of seismic waves called the secondary waves, will disappear. Thus, the outer core is liquid. At a certain depth, the waves are reflected and refracted. This means that the Earth must be layered. Well, that's all for today, grade 8 learners. We are finally done with our discussion. So, I guess you are now ready to take the quiz. Kindly prepare any sheets of paper for our evaluation. Good luck and God bless. Learners, kindly open your module on the assessment part, pages 16 to 17. Let us read the instruction together. Directions. Choose the letter of the correct answer. Write your answers on a separate sheet of paper. Question number 1. What wave causes earthquake to occur? Again, what wave causes earthquake to occur? A. Electromagnetic. B. Radio. C. Seismic. D. Sound. The correct answer is C. Seismic. Question number 2. What does P in the P wave stands for? Again, what does P in the P wave stands for? A. Parallel. B. Partial. C. Perpendicular. D. Primary. The correct answer is D. Primary. Question number 3. What kind of seismic waves arrive last at the seismic station? Again, what kind of seismic wave arrives last at the seismic station? Letter A. Love. Letter B. Primary. Letter C. Secondary. Letter D. Surface. The correct answer is letter D. Surface. Question number 4. Which type of wave vibrates parallel to the direction and travels in a push-pull motion? Again, which type of wave vibrates parallel to the direction and travels in a push-pull motion? A. Love. B. Primary. C. Secondary. D. Surface. The correct answer is B. Primary. Question number 5. Which of the following statements best describes primary wave? Again, which of the following statements best describes primary wave? A. It travels through a vacuum. B. It causes rock particles to vibrate. C. It is the slowest, largest, and causes the most destruction. D. It travels the fastest and causes rock materials to move back and forth. The correct answer is D. It travels the fastest and causes rock materials to move back and forth. Thank you so much for watching and see you on the next session through TV-based instruction. Again, I am Teacher Nelmmy Ferran from Andili National High School, Mawab District. Saying, dito sa TV Eskwela, sa pag-aaral, sama-sama. Bye-bye!